users were logged out and saw unauthorized purchases. A missing script-src directive in our CSP allowed a chatbot widget to inject arbitrary JavaScript. The Taint API experimental taint object reference is available in React 19, Canary, and Next.js 14+. In Next.js 16, it is stable under the experimental taint flag in Next.config.js. Ensure you are using React 19 or later. The API is not available in React 18. The article mentions enabling experimental taint but does not show the configuration. Here is the exact Next.config.js snippet to enable the Taint API in production. In production, the Taint API silently strips tainted data from client component props instead of throwing an error. This means a developer might not notice missing data in production. Always test with development builds and monitor for missing props after deployment. Let's break down security in Next.js 16, CSP, Taint API, and server actions security, how it works, and the exact mistake behind that failure. Next.js 16 security is a layered defense. CSP controls what scripts and resources the browser can load. The Taint API prevents accidental data exposure to client components. Server actions enforce origin-based access control, and React's built-in sanitization handles most XSS vectors in JSX. But these layers only work if they're configured correctly. Many developers set default-src, self, and assume all resource types are restricted, but default-src does not control inline script execution. Inline scripts are controlled exclusively by script-src. Without an explicit script-src, browsers default to allowing inline scripts, which is exactly what happened in our incident. Here's a proper CSP header with explicit script-src. It uses hash-based Allowlisting for inline scripts and allows a specific third-party origin for the chatbot widget. Note the use of strict dynamic for modern script loading patterns. Hash-based Allowlisting requires generating a SHA-256 hash of every inline script in your application. The hash changes when the script content changes, so any tampering produces a different hash and the browser blocks execution. For Next.js, inline scripts include the Bootstrap runtime and analytics snippets. This shell script extracts inline scripts from the production build output, computes their SHA-256 hashes, and outputs them. You can integrate this into your CI pipeline to generate CSP hashes automatically before deployment. The Taint API is React 19's mechanism for preventing sensitive server data from reaching client components. When you taint an object reference, any attempt to pass it to a useClient component throws an error in development and silently strips the data in production. Here we taint the entire user object after fetching it. The server component can still read the data and use it server-side, but if any code path passes this object to a client component, React will throw an error in development or strip the data in production. Server actions in Next.js 16 have a built-in security model. They are only accessible from the same origin by default. Cross-origin requests are rejected with a 403. However, server actions do not validate input by default. You must add your own authorization checks, input validation, and rate limiting. This server action includes authorization via session check, input validation using ZOD, and returns errors for invalid or unauthorized requests. Never trust that server actions are secure by default just because they're not exposed as REST endpoints. React's JSX automatically escapes string values, preventing the most common XSS vector. However, dangerouslySetInnerHTML bypasses this escaping. If you use this prop with user-controlled data, you must sanitize with DOM Purify first. This component uses DOM Purify to sanitize user-generated HTML before rendering it with dangerouslySetInnerHTML. It whitelists only safe tags and attributes, preventing script injection. Next.js 16 provides built-in CSRF protection for server actions through the same site cookie attribute and the origin check. For API routes, you must implement CSRF protection yourself using tokens. For API routes, implement CSRF token generation and validation. The server generates a token, sets it as an HTTP-only cookie, and validates it on subsequent state-changing requests. Rate limiting is essential for any public-facing endpoint, including server actions. Without it, a malicious user can call a server action thousands of times per second, exhausting resources. Use a distributed rate limiter like at /rate-limit with Redis. This sets up a rate limiter that allows 10 requests per 10 seconds. In your server action, you check the rate limit keyed by userid or IP. If exceeded, throw an error. Secret management has a critical pitfall. Next public environment variables are baked into the client-side bundle at build time. Any value with this prefix becomes visible in the browser's JavaScript source. Never put a secret in a next public variable. Access secrets via process.env without the next public prefix. Validate that all required environment variables are set at startup to fail fast if any are missing. CSP is the most important security header, but it should not be the only one. A complete suite includes strict transport security, X-frame options, X-content type options, referrer policy, and permissions policy. These headers together provide defense in depth. Add these 6 security headers in Config.js using the async headers function. This ensures they are applied to all routes and are version controlled. This is the same issue we highlighted at the start. Here's exactly why that happened. Our CSP policy had default-src, self, but no explicit script-src directive. Without script-src, the browser allows inline scripts by default. The chatbot widget dynamically injected a script tag that the browser executed because no CSP directive blocked it. The script exfiltrated session cookies to an attacker-controlled server. The CSP had default-src, self, but no explicit script-src, so inline scripts executed freely. A compromised chatbot widget injected a script that exfiltrated session cookies. The fix required adding an explicit script-src directive with hash-based allowlisting. We generated SHA-256 hashes for all 14 inline scripts using the CSP evaluator tool and added them to the policy. We also added strict dynamic and restricted third-party origins to specific domains. This prevented any unauthorized script from executing. This was the exact mistake in our incident. The CSP policy had only default-src, self, without an explicit script-src. This allowed inline scripts to execute, which the attacker exploited. Always declare script-src explicitly with hash-based allowlisting. Server actions are post endpoints with origin-based CSRF protection. They do not provide authorization, input validation, or rate limiting. This action deletes a user without checking if the caller is authorized. Always add authorization checks and input validation. The Taint API does not prevent server components from reading sensitive data. It only prevents that data from being transferred to a client component. If a server component reads an API key and uses it server-side, that's fine. But if it passes the key to a client component, the taint check triggers. React's JSX escaping does not apply inside dangerouslySetInnerHTML. If you use this prop with user-controlled data without sanitization, you open the door to XSS attacks. Always sanitize with DOM purify or avoid this prop altogether. Use these commands to verify your security configuration. Check that CSP headers include script-src, test the Taint API is working, and ensure server actions reject cross-origin requests. Let's run through some common interview questions. Design a layered security architecture for Next.js 16 handling PII, 4 layers, CSP with explicit script-src, Taint API for data, server actions with validation, and secret management. How does Taint API prevent data leaks? Taints object references, passing to client component throws error in dev, strips in prod. Security differences between server actions and API routes. Server actions have built-in CSRF origin check. API routes need manual CSRF tokens. And a few frequently asked questions. What is the Taint API? React 19 feature that prevents sensitive server data from being passed to client components. Can I use unsafe inline with nonces? No, unsafe inline overrides nonce hash allowlisting. Do server actions provide authorization? No, only origin-based CSRF protection. You must add authorization yourself. Let's recap the key takeaways. Always set script-src explicitly with hashes. Use Taint API to prevent data leaks. Add authorization and validation to server actions. Implement all 6 security headers. Ready to go deeper? Up next, bundle analysis and performance optimization in Next.js 16, then custom cache handlers, Redis, memcached, and distributed caching, then MDX, content management, and draft mode in Next.js and Next, config, TS deep dive, all configuration options explained. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.